Hello and welcome to the Optimizing Human Performance podcast. I'm Martin Jones.
And I'm Jonpaul Niven.
Each week, we talk to world-leading experts about how to unlock the full potential of people who operate in high-stress, high-stakes environments. In today's episode, you'll be hearing from Dr. David Putrino from the Icahn School of Medicine at Mount Sinai in New York. David's at the forefront of research into innovative ways to enhance human performance.
There's one probiotic that we've been looking at for a little while called Valionella. It actually breaks down lactic acid and turns the lactic acid into short-chain fatty acids at this prodigious speed. The evidence is starting to really pile up that that's a cool intervention for performance.
We discuss the stuff that works.
The one thing that outperformed everything that we tried to do was playing with people's perceptions.
The stuff that doesn't work.
We can actually tell you categorically that this is a waste of time and don't do it. And yet, I see the field reinventing itself over and over again.
And the exciting new possibilities for future research.
It's been a taboo topic for a really long time. But if we can use medications to treat disease, we should also hold the opinion that we can use medications to make people healthier, stronger, fitter, better. And I think that as these frontiers start to get explored, we're going to learn things.
David, welcome to the Optimizing Human Performance podcast. How are you doing?
I'm doing well. Thank you for having me.
You're very welcome. It's great to have you on. I'm really looking forward to this conversation. What we typically do to start off with, we'll just hand it over to you and let you just describe yourself. Tell us who you are, where you are, what you do professionally, and how you've got to where you are.
So my name is David Putrino. I am the Director of Rehabilitation Innovation for the Mount Sinai Health System, which is this big network of 8 hospitals here in New York City in the United States. And basically my role boils down to a single statistic, which is typically it takes about 17 years for us to translate something that can help people into something that is available to help people. And that is a ridiculous statistic. That is a number that is way too long and shouldn't be that long. And so our team in multiple domains is focused on finding technologies that we think can help and rapidly road testing them and getting them into the healthcare system so that they can do what they are supposed to do and help people. We have a very broad purview. So we view human performance as a spectrum. We work with people who are at, some might say, one end of the performance spectrum where they're unable to do anything for themselves. So we'll think about people who have end-stage motor neuron disease. So their disease has progressed to a point where they rely on a ventilator to breathe for them. They don't have eye movement. For those patients, we're investigating things like brain-computer interfaces. We've implanted 6 people with ALS with brain-computer interfaces that allow them to cognitively control a digital device. And from there, we go all the way over to the highest end of the performance spectrum, high-performance military performers, high-performance athletes, high-performance executives. And we work with folks on that end of the performance spectrum on the mission of performance enhancement. What can we be doing socially, cognitively, mentally, and physically to push them to the limits? So long story short, I get to work with a lot of really cool technologies and a lot of really cool people. And we also get to do a lot of cross-pollination, starting to think about, okay, well, what would a brain-computer interface for performance as opposed to survival look like? And can we take some of the substances and things that we're trying out on the human performance and human enhancement side, and can we bring it over to the clinical side and vice versa?
That's awesome. We're going to come back to that. I'm interested in that. What technologies, what kind of things can we do to improve performance? So in terms of your academic background, how do you get to a job like that? What's the route? Because I want to go back and retrain and get there.
Yeah, I'm constantly looking for people to replace me. So, I started out as a physio. So that was my clinical background and clinical experience has been working with people primarily with neurological disorders. So I was working with stroke and spinal cord injury, traumatic brain injury. And as I sort of delved into that role, I realized 2 things. The first was that there was a real interesting similarity between working with people with neurological injuries and studying to be a good neurophysio and working with high performance athletes, because in both cases, you're really trying to retrain an adult nervous system to do things better and do things more efficiently. And so there was a lot of cross-pollination that I could bring from that space that, in my opinion, hadn't really been attempted before and hadn't been done. And that's 20 years ago now. A lot of the physios that you see showing up to high-performance jobs often, as well as having a musculoskeletal background, have a pretty solid neuro background as well. But 20 years ago, we were really able to take some big swings and do some interesting stuff. Along those lines, I got a little frustrated with offerings that were open to our patients. And so I decided to do a PhD in basic neuroscience. So really animal research, hardcore neurophysiology, recording from single neurons, and really trying to understand how the nervous system learns and how it initiates movement and how it adapts when injuries occur and so on and so forth. And that took me down an academia rabbit hole for a few years where I was postdocing in the States, and I worked at some really great institutions. I got to work at Harvard and MIT and NYU. And it was really about 4 or 5 years into postdocing that I started to realize that there was this huge disconnect between what the scientists were doing and what they were saying that they were doing. NIH, National Institutes of Health, that's the big funding body here for biomedical research in the United States. They fund about $33 billion worth of projects per year. And in order to get an NIH grant, you sort of write down, well, if we answer this very basic science question, it will give us a greater insight into how people recover from stroke or how to make soldiers more survivable on the field or, whatever the case may be. And you have to write that for grantsmanship purposes, but then there was no follow through on that. That was my big problem. And so I got pretty fed up with that. And I was on the edge of leaving academia when I met my current boss, Joe Herrera, and he said, look, why don't you come over to Mount Sinai? We'll create a position for you and just make some noise, do some risky stuff that pays off, and you can stay, and it seemed like a win-win situation. I was like, look, this is the mission I want to build out, and Mount Sinai is big enough and powerful enough to allow me to do it in a way that can make some noise. And that was 8 years ago, and we've been pushing the limits ever since.
Yeah, they haven't sacked you yet. That's a good sign.
Haven't sacked yet.
That's awesome. Can we just talk about neuroscience just for a quick second? I know you said then there's a disconnect between basic neuroscience and maybe applied neuroscience, like what people are actually doing. One of my observations, and maybe even a frustration, is the world and his wife seems to be a neuroscientist at the moment. You get a lot of people saying they either are a neuroscientist or they're applying neuroscience. Like, what are we actually talking about here? What is neuroscience in terms of helping people live a better life, a healthier life, a more productive performing life? What is neuroscience?
Yeah, it's a tricky balance because I don't like to gatekeep people when they say that they're a neuroscientist, because neuroscience is such a vast field. Yeah. And again, I might be aging myself, but when I started a PhD in neuroscience, I had to explain what that was back in 2006. People were like, what? I've never heard of neuroscience. What is neuroscience? And I would explain, well, we're studying the nervous system in great detail in as many applied ways as we can. And as you start to think about how the nervous system affects the world around us, you start to realize how vast the field can be. My wife is a neuroscientist, but she's a social neuroscientist, and she studies the neurobiology of social isolation and loneliness. And her scope of neuroscience research is so different from my scope of neuroscience research. So there's a lot of really good neuroscientists out there doing a broad number of things. There are also some really questionable neuroscientists out there who are just tagging on to the hype that has been created around the field. And often, to be perfectly honest, when we're working with high-performance sports teams or high-performance teams in general, a lot of our job is sifting through the crap. A lot of our job is saying to coaches or performance specialists, stay away from that because here's the evidence on it, and it's not really living up to the hype that they're creating around the product. So a lot of the time, that's what we need to do.
David, you mentioned obviously there's a lot of rubbish, for want of a better word. We've used the term snake oil quite often on the podcast about concepts and ideas which don't have a solid evidence base. So could you give us an insight into one area within the field of neuroscience whereby there's been a lot of talk around the concept or the idea, but the evidence just isn't there.
Yeah, I think one of my biggest frustrations has been around the field of transcranial direct current stimulation for motor performance. So transcranial direct current stimulation is a method of non-invasive brain stimulation where basically the user will place electric charges onto their scalp and they will run a direct current stimulation protocol where electricity sort of goes from one pole to the other pole. And if all of the conditions are correct, presumably some of that electric current makes it into the brain and upregulates certain neural processes, downregulates others, so on and so forth. And basically about 20 years ago, there were a few studies that were put out there that showed that in very controlled circumstances, in people with spinal cord injury and stroke, you could upregulate the motor system and maybe even improve outcome if you paired TDCS with rehabilitation. The sports performance world took those early findings and exploded. They were just like, okay, here's a headset and you put it on, and if your players wear it, they're gonna learn faster, better, stronger, etc. There was a huge controversy around this. We started hearing about concepts like brain doping. How would we ever know if athletes are zapping themselves? At the time, the head of the National Institutes for Neurological Disorders and Stroke described TDCS as perhaps a cigarette that in 20 years, if everyone's zapping their brains, they're going to have brain cancer. There was a lot of chaos. Maybe 12 years ago, I was working with Red Bull and we were doing TDCS experiments, and we had failed experiment after failed experiment, which we published. And we were just like, this didn't really seem to work. And over time, now if you go to Cochrane systematic reviews, TDCS for motor performance does not work. And in fact, the Cochrane systematic reviews tell you that there is grade 1A evidence to suggest that it does not work. So it's one of those things where it's like, we can actually tell you categorically that this is a waste of time and don't do it. And yet I see the field reinventing itself over and over again, these new sort of TDCS devices, different form factors, different configurations, and it keeps coming back and being recycled. And the only one thing I want to say is that non-invasive brain stimulation as a field does have utility. It's just that you need to read the literature deeply and understand the use cases where TDCS, TACS, which is alternating current, and then direct nerve stimulation like vagus nerve stimulation. There are use cases for these things, but they're very specific and you need to understand the literature to utilize them properly.
Yeah, that's good to hear, because in a former life, one of my research roles, I was directed to oversee some research around brain stimulation to help out with some of this work. And I was skeptical, having read some of the papers, maybe even some of your papers, looking back at it now. But there was then a shift towards, well, if it doesn't work for motor performance, does it work for cognitive performance? So then there was a bit of a shift in the outcome, looking at sustained attention, working memory. Is the field of research in a similar place? Is there evidence to show that it doesn't work? It does work. What about for more executive functions? What we're looking at? Vagus nerve stimulation as well, that kind of thing, maybe.
Yeah, there is emerging evidence around vagus nerve stimulation to show that cognitive performance can be boosted with very carefully applied vagus nerve stimulation.
Yeah, I'm glad you say that. People, do not unplug your toaster, hack with the wires and try and zap yourself.
Exactly. You can go on YouTube right this minute and there's no fewer than 1,000 videos showing you how to make a homemade vagus nerve stimulator. And again, a lot of the challenges around non-invasive brain stimulation is making sure that you're hitting the right thing when you put this often fixed form factor technology onto your nervous system and zap away. And that's honestly one of the biggest issues that we face with non-invasive brain stimulation is dosing and hitting the right nerves and hitting the right areas. And so when I say, yes, there is promising data out there for vagus nerve stimulation and enhancing learning and enhancing motor performance, it's true, there is. But without the perfect device and without high-level experts applying the device to the user every single day, short of actually implanting the vagus nerve with a stimulator, often the evidence would point you toward you can more directly hit improvements on cognition and learning and so on and so forth with a high intensity interval training protocol right before you sit the person down to do some learning than you can with vagus nerve stimulation, because they're both doing the same thing. They're both dialing up your autonomic nervous system to a point where plasticity is optimized through upregulation of BDNF and other sort of neurotrophics. But with high interval training, you're definitely going to hit, you're definitely going to do it because you know how to push them from a heart rate standpoint, you know how to push them from an exertional standpoint. Whereas with vagus nerve, you're putting this thing onto their ear and hoping that you've put the electrodes in the right place. And I do hope that people actually crack the form factor where you can actually say, yep, you're definitely in the right spot. Yep, the right contact is definitely being made. Yep, we're definitely hitting the right dose parameters with the stimulation, because we do implanted vagus nerve stim, and we can do that with implanted vagus nerve stim. But with non-invasive, it's harder.
I had someone once ask me specifically about vagus nerve stimulation. There was a device that they'd seen sits in the ear, like a little earphone, trying to stimulate the vagus nerve close to the ear. And the question was, might he accidentally shit himself if it goes wrong? And I don't know, is that possible? Could that happen?
Oh, that'd be brilliant.
I always preface questions like this with everything is possible. That which can happen will, especially when it comes to the vagus nerve. But I would say I've never read on a warning label that shitting oneself is an adverse event. That would be common with vagus nerve stim. Yeah.
I said to him, I don't think so. But anyway, I don't know if he ever tried it or not. I think he withdrew from the study just on the off chance that it might happen to him. Can we flip the conversation then? JP's question around what doesn't work. What technology have you shown is your go-to? Where's the evidence strongest for this intersection of technology and performance? Are there any technologies out there that are really good?
This is a great question, and I think that human performance in general is such an incremental game, and so it requires a personalized approach to every single athlete. Like when we think about things that work with everybody with massive measurable gains, we're typically talking about substances that are banned. You know what I mean? So there are lots of substances that you can give to people that will give them a 20 to 30% bump in performance, and WADA has banned every single one of them. They're just not allowed. And often what we're doing is working on the edge of science to explore things that might be helpful or might one day be banned, but aren't banned yet. Like these are some of the things that are really interesting. Some I can talk about, some I can't. But generally, when we're digging into athlete performance, the biggest thing that we face is just trying to get them to do the little things right. Getting to bed at a reasonable time, limiting screen time before bed, getting good sleep, eating the right foods at the right times, sticking to the training regimen that their S&C coaches have put up for them. And then once we have those things in a good place, which is really hard to do, and sometimes in some teams, you never get that, so I'll preface that, like in some teams, the culture is so bad or the athletes are so uncontrolled that you're just not even going to get to that spot. But if you do get to that spot, then you can start building and start experimenting. And again, that takes a lot of trust with the athletes. They need to know that you have their best interests at heart and that they're going to work with you to do something special. But some of the stuff that we've been having really good responses to in terms of improving resilience to exertion are mitochondrial supplements applied appropriately. So things like NAD plus patches and working with CoQ10, nicotinamide riboside, things that help to reduce oxidative stress and improve mitochondrial function so that athletes can push further and harder for longer or can boost recovery times, seem to really, really help our athletes. One of the big challenges that we're facing there is finding good biomarkers of real-time oxidative stress and mitochondrial function, and that's been a challenge for the field for a long time. Currently, in the research world, we look toward doing things like muscle biopsies, where you look at buildup of amyloid and buildup of oxidative reactive oxygen species to understand how much mitochondrial dysfunction or balance that someone's in. But certainly, the evidence will point toward these sorts of supplements can boost things. We're also eyeing off some really novel probiotics that can also boost function. There's one probiotic that we've been looking at for a little while called Valionella. That is a bug that actually was discovered in marathon runners. It boosts in marathon runners after they run a marathon. And when researchers started to look at this bug, Valionella, they were like, oh, wow, it actually breaks down lactic acid and turns the lactic acid into short-chain fatty acids at this like prodigious speed. And so now, of course, performance groups are starting to build out Valionella as a probiotic to boost recovery after sports. And again, the evidence is starting to really pile up that that's a really cool intervention for performance.
That's really interesting. You mentioned earlier this spectrum of people who are not functioning, ill, people who've got disease to high performance. Well, you just described them with mitochondrial function. Is that an example? These drugs or things, were they originally for things like muscular dystrophy that have then people have gradually used them for performance reasons? Is that kind of how it emerges?
Actually, a lot of mitochondrial supplements were developed the opposite. So a lot of the work around mitochondrial dysfunction and mitochondrial function in general was done by good, hardworking exercise physiologists who were trying to understand how athletes can perform. And they were doing CPET testing and taking muscle biopsies and understanding how energy gets to muscles and how we can get more out of the muscles. So it was actually developed in the performance world, and supplement companies started to sort of say to athletes, hey, this stuff is safe, it's natural, it's water approved, and it could boost your function. Interestingly, in our world, I really started to do deep dives into it and get very familiar with different mitochondrial supplement protocols and escalation protocols because of the work that I've been doing in long COVID, which has been all consuming for the last few years, where we've seen very clear evidence of mitochondrial dysfunction in people with long COVID. And they get a symptom that's called post-exertional malaise, where if they exert themselves even a little bit, in our most severe cases, we're talking about if the lights are on and they're just doing visual processing, or if they need to brush their teeth, that can knock them out for a day. And when you provide them with mitochondrial supplementation, it doesn't cure them, but it opens the window a little bit more that they can exert themselves a little more. And then when you start to read the literature a little bit more, because I was like, okay, this seems to be helping, and bless up to the functional medicine doctors actually who were really coaching me on this, then I started to see, hey, actually the research and there was a lot of work done around these in terms of athlete overtraining syndrome or burnout, where a lot of exercise physiologists were trying to explain burnout by understanding that it was an energy production issue in the athlete. And that was what was breaking down as they have overtrained.
That's nice to hear. Usually, in my experience, it's usually sports science, human performance lags behind other areas. We beg, borrow, and steal from other areas. So that's a nice example of maybe where we maybe not led the way, but we certainly helped some people. So that's always nice to hear. You talked about Red Bull. You mentioned that you did a bit of work in Red Bull. Can you tell us a little bit about what you did at Red Bull?
Yeah, absolutely. So total coincidental meeting, Australian mafia story. I just moved to New York and I was attending an event at the Australian consulate, because what do you do when you're a lonely Australian? You just sort of like try and find other lonely Australians, I guess. And
I've got an image of Flight of the Conchords in my head at the moment of the Australian consulate and the New Zealand consulate.
Present, yeah.
Just like that.
So I was there and they had Tim Cahill speaking, Australian football player. And one of my friends had told me to go because he's football mad and I am not. So I was impressed to see Tim, and he gave a really amazing speech, but I was sort of just hanging down the back while everyone like mobbed to the front to meet him. And it was basically me and this one other lady who were just sort of hanging back. And so I wandered over to her and I was like, hey, not a football fan. And she was like, oh no, I'm Tim's handler or something. She said something to that effect. I was like, oh wow. And I was like, do you work for the Socceroos? Because he was playing for the Socceroos at that time. And she was like, no, I work for Red Bull. He's a Red Bull sponsored high performance athlete. And I was like, oh wow, that's really cool. I didn't even know at that time. I was like, Red Bull's a drink. That was my level of understanding. And she asked me what I did. And I said I was a neuroscientist. And she lit up and she was like, neuroscientist? That's so exciting. Back when neuroscience was just saturated enough to be cool and not eye roll. And she said, the head of human performance at Red Bull is looking for a neuroscientist. His name's Andy Walsh, and I'm sure he'd love to meet you. And Andy was another Aussie. And so I went out to LA to meet him, and we started chatting. And Andy, as far as I'm concerned, has always been at the forefront of what's cool. And when Andy's telling you about something, he's already on to the next thing. So it's easy to hear Andy talk about something and be like, well, that's not so bleeding edge. And it's like, yeah, because he's already 8 years ahead of that, like thinking about the next thing. So I got to meet Andy, and we definitely had a good rapport, and we started working on a few projects together, really trying to understand what was happening when we pushed athletes to different limits. So we would push them to the limits of endurance and stimulate their brains to see if we could push them beyond limits of physiologically imposed fatigue. We would take them to different altitudes and see how well they could perform at different altitudes and what was the limit of muscle fatigue when blood oxygenation levels were different and environmental oxygenation levels were different. We would do a series of camps called Performance Under Pressure, where we would create instances of life-threatening situations. So they were controlled instances, but to the athletes or to the performers in general, they felt like they were under life-threatening situations. And we would just study how they would react, and we would study what their physiology did and try and understand how well they could perform under pressure and so on and so forth.
Sounds like a lot of fun. It sounds like you just got a playground of these Red Bull athletes, and you got to play with some cool kit.
It was a lot of fun. It was a lot of real pure discovery, which I really miss, because once Andy moved on from Red Bull, they definitely became more conservative in their approach, and Red Bull High Performance has turned into Red Bull APC, Athletic Performance Center, where they took all of this wisdom that they built up over 10 or 12 years of experimental craziness, and now they're using it to train athletes, which is awesome. But I do sort of get misty-eyed over the good old days where we used to put someone face-to-face with a grizzly bear and see what they did.
Run away? Or did they?
In most cases, run away. In one case, we actually had to intervene. But yeah.
Wow. I'm intrigued. What sport was that individual from?
That individual was a fencer, believe it or not, an Olympic-level fencer. And, whilst everyone else's instinct was to run away from the bear, he sort of roared and ran toward the bear, and the trainer... Because what they didn't know was it was a trained grizzly bear that was very gentle, and the trainer had to just stand out in front and be like, idiot, turn around. You turn around and walk away,
Yeah.
David, from that body of work, was there any interesting insights which you sort of came across which are maybe transferable to other communities? So maybe sport, just general sport, or maybe our demographics of sort of these in extremist population groups?
I think there were always lots of insights that we would come across. We studied endurance. So a lot of the stuff I was telling you about altitude and electrical stimulation, they were all part of a series of experiments that we call Project Endurance, and trying to push the limits of endurance without using banned substances. Again, that's the caveat. When it came to endurance and pushing people beyond their physiological limits, I would say the one thing that outperformed everything that we tried to do was playing with people's perceptions. So someone who was telling you, I'm completely exhausted, I can't go any faster, if you showed them a personal best that they knew was their personal best and set them against their personal best, they would raise the bar and go a little bit faster to beat their personal best. And what we did in this case, that categorically in all of our endurance athletes, we got another 5% out of them, even though they told us that they couldn't go any further, was we set them up against a racer that was on a motorized bike, and we told them that that was their personal best velocity, but it was actually their personal best plus 5%, and they matched that 5%. So not saying that this is an amazing training tip, but I am saying that when we threw everything, supplementary oxygen and non-invasive brain stimulation and all of these experimental things that the literature was telling us was like the way to push an athlete a little bit further or get a little bit more juice out of the squeeze, ultimately tricking them was the best way to get their nervous system to just give them a little bit more of a bump in performance in training, which was really, really interesting and tells us a little bit about mental frameworks around endurance and what we hold in reserve in the tank and how to access that. In terms of the work that we did around performance under pressure and other concepts like flow, which Red Bull was really chasing. The thing that really struck me was how individualized concepts of pressure and stress were for each of our athletes. For instance, obviously, some of our athletes were very comfortable being held underwater during a breath holding task, but less comfortable being face to face with a grizzly or face to face with a snake. Some of our military performers who took part in the experiments, if I was looking at their heart rate and their stress hormones, I wouldn't know if they were face to face with a snake or just going on a light jog or having a cup of coffee. But pairing them up with a Cirque du Soleil dancer and asking them to dance in front of a group of people, and suddenly their stress hormones are off the charts and they're feeling very awkward and they're not so happy with what's going on. So social stresses versus physical stresses versus danger stresses. And so again, the lesson here is if you want your athlete to be the highest performer, you need to understand your athlete, because what we could categorically tell you is that stress levels affect performance, but understanding what actually stresses your athlete out or your performer in general is a different story. And so when we would see the performance dips was the unpredictable thing. And so the only wisdom that we could take from that is we need to work to understand our athletes, to understand why they're getting stressed out, to understand why their performance is dipping, to then optimize performance. And it was a very similar situation for flow. What a dancer would describe as flow versus what a military performer would describe as flow versus what an endurance athlete would describe as flow was so different. The feeling was the same, the trigger was different, and that was really interesting to me.
You just got me thinking there that you mentioned earlier that concept of neuroplasticity, and obviously if we're trying to develop skills within young children, for example, part of that long-term athlete development, the broader exposure they have to skills or the application of skills, more likelihood they're going to achieve success. And obviously I'm simplifying that as much as I can. But do you think that could be the same then in regards to resilience? If we expose someone to a variety of stressors in different situations, we take them out of the comfort zone. So someone who is very comfortable in a high stress, high stakes environment, but then we throw them in front of a dance audience and say, right, dance. Could that idea, that concept, that exposure to a range of stressors enhance resilience?
Yeah, it's a good question. I would disagree. I would say that's a good way to traumatize someone. And interestingly, I think that unfortunately, a lot of the ways that we train people in high stress situations is by traumatizing them systematically to the point where they don't respond to things anymore. But that's because they're traumatized. And so then that has consequences down the track. So I'll say a couple of things because you brought up neuroplasticity and diversity of experience. So I do think that diversity of experience is a good way to boost neuroplasticity and creativity. And there's loads of literature about this in the teaching and learning literature. If you want to place someone in a place where they're most able to learn in a safe and supported way, throw them into the deep end of the pool of like, hey, you want to learn Italian? Let's go to Italy. That's the best way to do it, and let's throw you into the culture, no safety net. And so long as you're feeling supportive and in a place to learn, your brain is going to open up and going to be ready to learn. Green spaces and access to nature boost neuroplasticity. And so when we think about training camps, the reason that training camps work, the reason that training camps are so successful and everyone does it, is you're doing the same shit in a different environment. You're creating a shared experience, which improves bonding. You're creating a new and novel experience, which boosts neuroplasticity. And so suddenly you've got a group of people who are bonded by a common experience who are suddenly starting to learn more aggressively. If you're trying to boost resilience, the most current and up-to-date literature tells us that what you want to do is create strong bonds in the group that you're working with. Resilience, what we're seeing over and over again, is a social resource. So yes, people can be individually resilient. And in fact, the Dean of Icahn School of Medicine at Mount Sinai, Dennis Charney, is an amazing resilience researcher. He studied resilience in high-performance military. He even identified neuropeptide Y, which is a neuropeptide that is associated with higher levels of individual resilience. So it can be an individual trait. However, I would take a resilient group in terms of building individual resilience over someone who's individually resilient in an unsupportive group any day of the year. Like, the least individually resilient person is more resilient than the most individually resilient person if they're in a group where they feel every single person has their back, they're safe to try out whatever they want to try out, and they can go for it. So that would be my answer to the question.
I've definitely observed that the social dynamics is a fundamental resource for resilience. 100%. It's something that I've experienced and observed time and time again. So yeah, it makes so much sense when you say that. Could we just take a couple of steps back? What is neuroplasticity? Some people throw it out every other sentence to try and legitimize what their intervention is supposed to be doing. Can you just give us a real brief, like, what are we actually talking about? What is neuroplasticity?
Yeah, neuroplasticity is a term that really just describes the nervous system's ability to change based on incoming experiences and outgoing motor commands or outgoing commands in general. And for the longest time, we thought that the central nervous system was static. You couldn't change it. The physiology was the physiology, and that was it. And if you had a stroke or a spinal cord injury or a traumatic brain injury, that biology was destiny, and that injury was that injury, and you wouldn't recover from that. What we started to learn in the 80s was that actually that's not the case. If you can find a way to get the neurons around an injury to slowly activate themselves and be responsive to things in the outside world, they can rewire, they can, based on activity-dependent work, they can start to form new pathways, and then recovery is possible to a certain extent. And then people started to realize that neuroplasticity is, of course, present in everything. So it started from this extreme example of injury, but then, well, of course, learning. What we do with our kids is neuroplasticity. You know, we sit them down, we put them in a room, we shout information at them, and some of it sinks in, and new pathways are created, and that's neuroplasticity. And then we started to realize that, well, when we're learning new skills, that's neuroplasticity. So neuroplasticity is occurring at all times. We are all, right now, people listening to this podcast, the three of us talking together, neuroplasticity is occurring because new memories are being laid down. Perhaps old held beliefs are being challenged or altered in certain ways. And all of that is happening because different synapses are rewiring. So neuron A is now connecting more strongly with neuron C than neuron B, and therefore there's a change in output. And that's happening on a scale of thousands or hundreds of thousands or even millions of neurons. We've also learned that neuroplasticity can be upregulated by things. So there's been a series of beautiful experiments in motor physiology to show that it's not just repetition. In fact, you can ask someone to do 10,000 repetitions of an easy movement, and you won't get any neuroplasticity in their motor system unless you add an element of interest or engagement to the task that you're asking them to do. And then the motor system will change. Again, bless up to the teachers, because they are the ones who have been saying this for years. If you want someone to learn, you got to make it interesting. You got to make it fun. You got to make it engaging. Somehow we didn't get the memo in performance training for a really long time, or in rehab. It was just like, sit down there and do your 50 repetitions. And it's like, well, actually, no, you need to be present. You need to be engaging them. You need to be coaching them in order for the neuroplasticity to occur.
David, one of your YouTube videos that I've seen, or maybe not your YouTube video, but it's Red Bull. You feature in it. Got a shock of long black hair, as I recall, in that particular video.
So the days.
Tell me about it. But in one of them, you're working with a group of surfers, and you're using lots of different wearable technologies, instrumenting the board, using drones, all this kind of stuff. What are your thoughts on that sort of technology for defense and security or high performance sport? Like, what are the good bits of wearable technology that people can use?
Yeah, I definitely think that wearables can enhance people's understandings of their own performance. And in general, I would say that wearables are really good for helping you get the simple stuff right. So I do think that there is utility in things like Whoop bands and Aura rings and things like that, so long as you're using them to better understand your own patterns and seeing where you can improve them where possible. So I think with high performance athletes and also military performers as well, I often recommend for some of these folks to just turn off the recommendations, turn off the notifications, and just look at the data. Because if you're an NBA player and you're wearing a Whoop band, it's going to tell you that your sleep is trash and you need to stop what you're doing. Otherwise, things are going to be catastrophic because you're not getting enough recovery and so on and so forth. And the reality is that's your schedule. You're going to play 5 games of basketball this week, and you're going to have to train, and you're going to have to travel, and your sleep is going to be garbage. And that's how it's going to be for the entire season. So it's not really helpful to have this Whoop band reminding you that if you keep doing that, you're going to die. Like it's just not good. And similar with military performers, or one of the projects we did was with our endovascular neurosurgery team. These are, a team of elite neurosurgeons who take clots out of people and stop brain bleeds and things like that. Whoop was just freaking out, an hour and a half of sleep every night. Oh my God. But giving them that lens and being able to more gently coach around okay, well, you actually do have a 3-hour break right now, and sleep can be cumulative. You can get 3 hours of sleep now and it will benefit you. Go and take a sleep now, because that's going to improve your performance over days, and giving them the data to actually help them see that they improve once they do that small thing that is helpful for them goes a long way to building trust. Because I think I speak for most people where it's sometimes if you're just doing the thing and getting away with it. So if I pull an all-nighter working on a project and then I go to work and I just make it through the day, sometimes in my mind that's equivalent to, hell yeah, I was able to do that thing and then still perform at a high level. When really, well, my coworkers thought I looked like shit. I probably wasn't contributing much to the meetings. And that brilliant email or paper that I thought I wrote really, really well, when I revisit it 2 days later, is just gibberish. And I think that wearables, especially some of the more cheap and easily available wearables that just give you steady data streams, allow you to see that. They allow you to see the benefit of doing the things that you're doing. But I don't think that we're yet at a point of individualized advice, or at least I think that the intersection of these wearables with an elite performer lifestyle is not relevant.
Yeah, I agree. I find that wearables are a really useful conversation starter. When you're supporting a performer, you can individualize based on some of the data they're getting from their wearable, but it can be easily overinterpreted, right? It's very easy to misinterpret what's coming off that wearable.
Definitely. So David, obviously with wearables, you get a lot of noise, a lot of data, a lot of potential information coming through. If you were working with an athlete in any setting and you had to pick your big 3 pieces of data which they should pay attention to, what would they be?
So I'm going to be annoying, and I'm going to say that in general, when we work with athletes and we work with wearables, it really comes down to setting intentions first. So it's why are we using this wearable? What do you best want to understand, and so on and so forth. But if I was going to say what do we use most often, I would say sleep quality is one of the things that we use most often, and then try to intervene on, because the extent to someone wakes up feeling refreshed is just instrumental to everything. Heart rate variability, I think, is something that is really starting to help us to predict good days and bad days based on how things are doing. And I'm going to throw an interesting one in there that isn't present on a lot of wearables right now, but I'm watching it really closely, is perfusion index. So this is a stat that is starting to show up on some of the more interesting wearable pulse oximeters and things like that athletes and performance athletes are starting to get into. And it tells you how well oxygenated your tissue is. And I think that has massive implications for performance. And I think it's something that we should be paying attention to, both in terms of its variability. So beat to beat, how much is perfusion index changing, which can tell you a little bit about your vascular function, day to day, but also just in general, are you having tissue oxygenation issues, and how can we improve that with diet and supplements and so on and so forth?
If we go back to where we started, you started off by telling us that your job title had innovation in it. And you also made the point that sometimes innovation can take a while, that we go from the lab bench to the electronics shop or whatever way people may be buying some of their technology, can be 17 years. Can you, to wrap up, give us a peek behind the curtain? What's on the horizon for the next few years in terms of where are the innovations coming? What might we see that can help people perform in the next couple of years?
Yeah, I think that there's a lot of interesting areas that are coming up. We've spoken a lot right now about physical performance, or at least physical sports and physical things. Obviously, esports is coming. I think 2028 will be the first time it's tested as an Olympic sport. It's already a sport that is capturing Gen Z well beyond what a lot of the physical sports are doing. And Gen Alpha, forget about it. They're all online and they're all thinking about esports performance. So I think a lot of the work that we're exploring is ways that we can enhance neurological performance, ways that we can move the needle on what's capable in terms of human cognition. And that is including brain stimulation, that is including implantables, that is including different sorts of peripherals. Maybe you're not just playing with your hands, you're playing with your head, you're playing with your mouth, you're playing with eye movements, in addition to what might be down the track in terms of brain-computer interfaces. So that's an area of interest. And we've been doing a lot of work with adaptive esports athletes right now, folks with disabilities who want to compete at the same level as esports athletes who don't have disabilities. And in 2025, in collaboration with Logitech, we're going to have the first ever brain-computer interface only esports competition, where only people who have brain implants will be able to compete, and they'll be competing cognitively. So this is coming, and it's a really exciting area. On the other side of the fence, as we start to think about how the body can be more resilient, how we can be pushing people, I think, like it or hate it, we should be looking at the enhanced games and seeing what's going on there, because the mission there is very, very simple. The mission there is, if we can use medications to treat disease, we should also hold the opinion that we can use medications to make people healthier, stronger, fitter, better. And it's been a taboo topic for a really long time. But I think that as these frontiers start to get explored, we're going to learn things. And that area of using drugs like rapamycin, which is an mTOR inhibitor, which can boost our immune system and lower inflammation and just make your body more resilient to a lot of different challenges. It's interesting to me, the idea of metformin that can improve mitochondrial function and enhance your metabolism, the idea of GLP modifiers. So Ozempic is probably the most famous of these, but there is supplements like allulose that can really enhance your ability to process sugars and control appetite and things of that nature. I think we're entering into a really interesting area. And I think that, again, rather than creating taboo around these topics, we should be really methodically and unemotionally studying these things as we think about the future of sports performance.
Well, I for one, am looking forward to the esport brain interface experiment. I think that'll be amazing to watch. Frightening at the same time. I think what else we might be able to do and control with our brains whilst doing other things, but super, super interesting. If people want to follow your story, they want to reach out to you or follow you on any social media, how do people best do that?
I would say I'm terrible at most social media, but I'm probably most active on Twitter and Blue Sky. And my handle there is the same. It's just @PutrinoLab. And then Mount Sinai websites and things like that they're easy to follow some of the work that we're doing as well. So, and then I've got Instagram, and it's all @PutrinoLab if you look for me.
Yeah, we'll get those in the show notes so people can find them more easily. David, what we like to do is to wrap up by offering you the opportunity to give us the final words. This can be a reflection on something that you've already talked about. It may be just reiterating an important factor. It could be just telling us something you haven't told us yet. So a big thank you from me. Really enjoyed today learnt tons. I feel like I am 10 times more neuroplastic. Is that the right phrase? Have I got it right? I don't know. It's something's happening up there. I'm sure it is. But yeah, thank you very much. So over to you. How would you like to wrap this episode up?
I think I would just say one of the things that I often say is that if someone's telling you that they have the silver bullet, they're probably selling bullets. So when it comes to human performance and performance enhancement, it takes a village. There are no easy ways forward. It really relies on a team that trusts one another to work together toward a common goal. And all of the bells and whistles and the technology that we've been talking about today, they can be helpful. But at the end of the day, human performance really comes down to people and people liking each other, trusting each other, and working together.
That's great. Thank you, David.
Thank you so much. This is so much fun.
Bro, thank you.
That's it for this week's episode of the Optimizing Human Performance podcast. Thanks for tuning in, and if you found this valuable, take a moment to rate and review the podcast. If you know someone who'd benefit from today's conversation, then please share this with them. We're always keen to hear your thoughts. If you have feedback, guest suggestions, or topics that you'd love us to cover, then email us at info@ophp.co.uk or connect with us on LinkedIn. Until next time, keep striving, keep improving, and keep optimizing your performance.